Greetings, math fans. All right, so today is day 3 of probability, and this is actually a really good topic. It's a topic that kind of is very useful in life, and it uses probability. But not that I'm trying to promote gambling, but this is kind of it's something called expected value, and what it does is it says, hey, what is your expected outcome? Are you going to make money, or are you going to lose money, or are you going to break even? Okay, and so let's kind of get started here with the note sheet. First of all, definition. Expected value is the long-run average value. And notice, math fans, I underline this. I'm going to underline this in red here. It's the average value over many trials. To calculate the expected value, you would take a possible outcome and multiply it by its probability, and then add it to the next possible outcome times its probability, etc. So mathematically speaking, this is what expected value is. It's the actual the A is the actual outcome, and P of A is the probability of getting that outcome. B, again, outcome, probability of B, which is, what is the probability of getting that B, etc. And you keep adding that. So start out really with an example. It's a good example. This is find the expected value of rolling a die. Since the outcomes for rolling a die are 1, 2, 3, 4, 5, or 6, each has a probability of 1/6. You guys know that already. The expected value is, and basically this is what I have here, this 1 is the actual outcome. Okay, it's an outcome. I'm getting a 1, and the probability of getting a 1 is 1/6. So I multiply those together. And then here's my 2. Probability of getting a 2 is 1/6, 3, 1/6, and again all the way up through 6. These probabilities, 1/6, 1/6, 1/6, these all add up to 1. Okay, or sideways smiley face. So the expected value is 3.5. And the question underneath here says, what does this mean? Clearly, for one roll of a die, you can't roll a 3.5. It doesn't make sense. You don't go, oh yeah, I think I'll roll a 3.5. If you're at the craps table and you're rolling dice and you roll a 3.5, they're going to kick you out because there's something wrong with the dice. Okay, you just can't roll a 3.5. But here's the deal. If we roll a die 10 times and record the results, the sum of the results should be close to 35, because 3.5 times 10 is 35. Therefore, the long-run average value or expected value is 3.5. So that's the average value if you did it a whole bunch of times. It's not saying you're going to do it on this time. It's saying over the course of a long time, what is the average roll going to be? And it's 3.5. Okay? Very important. Most of the time, the expected value can be used to help determine the long-run average dollar amount you can expect to win, hence gambling. And I talk about gambling a lot in class, and not as a way to make money in life and to have a career, but as a way for entertainment and you try to beat the house. And as long as if you're a smart gambler, you can not lose as much money. Okay. Anyway, let's look at the first problem here. You flip a coin. If you get heads, you win $4. If you get tails, you lose $2. What is the expected value of flipping a coin? So basically our event is you win $4, so it's $4, and the probability of getting heads is 1/2. Okay, plus you lose $2, so make sure you put -2 there because you're going to lose $2, and the probability of getting tails is 1/2. And that's all it is. So that equals 1. So the meaning behind this is, on average, I like to use the word on average, you will win $1 for every flip. Okay, on average. Because if I play the game one time, I'm certainly not going to win $1. It's impossible. I'm either going to win $4 or I'm going to lose $2. But if I keep playing and playing and playing and playing and playing, if I play it 50 times, on average I'm going to win $1, so I should have $50 in my hand after playing it 50 times. Okay? All right, number 2, you roll a die. If you get a 2 or a 4, you win $5. If you get a 1, you win $20. And if you get a 3, 4, or 6, you must pay $14. What is the expected value? Well, again, we're rolling one die, so you don't need to make a dice chart, but you guys know that the probability of getting any one of the numbers is 1/6, right? So let's start out with the first one here. If you get a 2 or 4, you win $5. So I win $5, And a 2 or a 4, that means it's 2 out of 6, right? And the next one, if I get a 1, I win $20. So I win $20 if I get a 1, which is 1/6. Now what I don't want you to get confused of is the first problem I did, I actually used the number. I used the 1, 2, 3, 4, 5, 6, if you look at the top of your note sheet there, or middle of your note sheet. Here I'm assigning a dollar amount to the die. Okay, so don't try to use the value of the die. I mean, if I just said what's the expected roll value, then of course you're using 1, 2, 3, 4, 5, 6. But if I said, well, if you roll a 1, you get this much, a 2, you get this much, then you assign the monetary amount to the die. But you got to make sure you have a probability in there too. It's very, very important. Okay, and then I lose, so I must pay $14. So it's negative 14, and a 3, 4, or 3, 5, or 6. It's 3 out of 6, or 1/2 of those rolls, right? And if I multiply all that out and add it, I get negative 2. So again, the words on average, so very important, on average, you will lose $2 for every roll. Okay? So a good way to explain it, right? As opposed to saying you'll win negative $2, it doesn't even really make sense. You don't go, woo, I'm a big winner, I won negative $50. Okay, you're a loser. Well, that's kind of sad saying, but you lost the money. Okay, so make sure you tell me you either win or lose. Okay, let's keep going here. Number 3, you are asked to draw a card from a standard deck of cards. If you draw a club, you win $5. A jack of spades wins $7, and you lose 50 cents for every red card you draw. What is the expected amount of money you will win? Okay, so that's interesting. So you're going to win $5 if you draw a club. And you guys agree they're 1/4 of the cards are clubs. And a jack of spades, you win $7. And there's only one jack of spades. And you lose 50 cents for every red card. So negative 0.50 for a red card, and half of them are a red card. Now notice it's not really that complicated because there's no overlap here, right? These are kind of mutually exclusive, if you guys remember the words. So I didn't have any red cards overlap with other red cards in here. Okay, so kind of pretty straightforward here. Multiply all that out, and I get 1.13. Now, please, math fans, when you're giving me an expected value in money, please round to the nearest cent. Okay, don't round it to 8 decimal places, or don't round to 0 decimal places. Everything is, if it's dollars, then you got to give me dollars and cents. Okay, so it's 1.13. So you basically win $1.13 on average. Ooh, there's that word again. For every pick. Oh, that's a good game. I would play that one. Okay, if it's positive, obviously you're going to make money. Not always, but in general. Okay, so this is kind of a good time to even talk about expected value. Again, it means on average. When the lotto gets up to, it all depends on which lottery you play, but when it gets up to maybe 150 million, 200 million, 300 million, 400 million, the expected value is actually positive. Now you can't look at that and go, oh man, the expected value is positive, I'm just going to buy some tickets and I should make money on it. Well, that's not the case. That's on average, remember. So if you played it millions and millions and millions and millions of times, on average you're going to make money. Okay? But if you play it a couple times, which most people just buy a few tickets, you're not going to win. Okay? Again, you can't play the lottery based on, gee, my expected value is positive, I'm going to win a lot of money. That's only on average. And on average could mean playing it, 500 million times. Okay? So don't get fooled by expected value being positive. It's nice, especially when it's some simple game, but when it's, the number of chances are in the hundreds of millions, not a good deal. Okay, let's look at number 4. Oh man, this is so exciting. Depending on where the spinner lands, you'll either win or lose a certain dollar amount. If you get a 1, you'll lose $1. If you get a 2, you lose $1.50. If you get a 3, you win $2. If you get a 4, you lose $2.50. And if you get a 5, you win $5. Okay, so that's pretty good. What is the expected value of one spin? So on average, how much do you think you're going to win or lose? Well, what I need to do is I need to first figure out how many 1s, 2s, 3s, 4s, and 5s there are. So if I count them, I have 4 1s, I have 4 2s, I have 3 3s, I have 3 4s, and I have 2 5s. So if I add all those up, I get 16 outcomes. I need that for my probability. Okay, so let's look at it. Now, if I get a 1, I lose $1. So that means -1, I lose $1, and the probability of that is 4/16. Okay, if I get a 2, I lose $1.50, so minus $1.50. Brutal. And that's also 4/16. And if I get a 3, I win $2. So it's positive $2, and that is 3/16. And if I get a 4, I lose $2.50. Brutal. So minus 250, and that's 3/16 as well. And if I get a 5, I win $5. Sweet. And that's only 2/16. Okay? So if I add all that up, my expected value is equal to -0.09375. I wanted to do that just to show you the long decimal here because it's going to kind of come in handy when we're doing part B. So basically, as far as money is concerned, we're going to, you want to give it as -0.09. So you're going to say will lose on average 9 cents, 0.09 for every spin. Okay, so did you play it? No way, man. Every time I play, I'll lose 9 cents on average. Now you might get lucky in your first spin, you might get a 5, and then you quit because you got, oh, I got $5, and you quit. Okay, but just like any machine, any slot machine, any gambling in Vegas, if you keep playing, you're going to lose. Everything is set up so the house has a little bit of an advantage. Just what it is. I mean, if you had the advantage, everyone would play that game, and the casinos would go out of business. Okay, but think about it. Those casinos are billion-dollar casinos. They're beautiful, beautiful casinos in Las Vegas or Atlantic City. Beautiful, beautiful casinos. And believe me, they don't build those casinos on giving lots of money away. Okay, so they make those casinos based on people losing money. All right, so part B, it says, what are the expected value if you have 100 spins? Now, what you're going to do is you're going to multiply that expected value times 100. But what I don't want you to do is, I don't want you, so I'm going to even write here, don't use rounded values. Okay, especially when you're multiplying. You just don't do that. It doesn't make sense. So what I'm going to do is I'm going to use this number that I used right here, and I'm going to say -0.09375. In fact, you're going to use a number that you have in your calculator, okay, and you're going to multiply that by 100. And then you get -9.38. Okay, so you're going to lose $9.38 for 100 spins. Okay, I will take off if you guys come up with an answer of 9 cents and then you multiply it by 100 and you get $9 and you say I'm going to lose $9. I will take a point off for that because you're not really losing $9. You're losing $9.38. That's a big difference. Okay, so don't round your answer, especially when you use well, I shouldn't say especially when you use an answer for another calculation, you never round it. Okay, that's a very bad thing to do. Okay, let's keep going here. Number 5, great problem. You spend $5 for a raffle ticket to win 10 grand. 250 tickets will be sold. Okay, what is the expected value of this raffle? So, well, here's the deal. Now, some people just want to do, you want to find the probability and multiply it by 10,000. But here's the deal. What's the probability of losing $5? Well, isn't it 100%? You're giving the person $5. You've lost it. Whether you win or lose, the raffle, you still lost $5. You're handing them $5. So the probability of losing is 1. Okay? And then I can win $10,000. What's the probability of winning $10,000? Well, there are 250 tickets, so it's 1 over 250. Okay? So I think I might have said this before, but these don't always necessarily have to add up to 100% or 1, because in this case here, you're guaranteed to lose it, but then there's a probability that you could win some money back. Okay, if we're talking like the problems I did before was a dice where everything is included, you're looking at 1, 2, 3, 4, 5, 6, or flipping a coin, heads and tails, of course that's going to be 100% or 1 because all of them are included here. But here, it's just a little bit different. So again, you're losing the $5 because I'm handing them $5, and then the probability of getting 10 grand is 1 out of 250 because of that many tickets. So my expected value turns out to be $45. Okay, so I'm just right here. You're going to definitely lose $5 because you just gave them $5. Okay, so basically, on average, you will win $45 in this raffle. Again, are you going to win $45? No. I'm either going to win 10 grand or I'm not going to win anything. Is it a good raffle to play? It's not bad. Would I buy a ton of tickets? No. You buy one ticket. It's kind of like the lottery used to say. You got to be in it to win it. If you buy 0 tickets, then the chances of getting anything are 0. You haven't lost money, you haven't won money. Okay? So just remember, this is 40. On average, you're going to win $45. It's probably a good thing to do. But you'll never win $45. You win 10 grand or nothing, and you'll probably win nothing because it's 1 out of 250. It's pretty bad. Okay, but that is what the expected value is. Okay, last thing on this sheet here, math fans, it's a definition. A fair game is when the expected value equals 0. Okay, that's important. People get confused and they say 1 sometimes. Think logically. If I said the expected value is 1, that means I'm winning $1. It's not a fair game. If it's 0, the casino's not winning or I'm not winning. Okay, so a fair game is expected value is equal to 0. Nobody wins and nobody loses. So let's look at this nice little friendly problem here. You spend $10 to roll a die. Oh, I spent $10. So I lost $10. It's very sad. Probability of losing $10? 1. I'm going to lose $10. Okay, so let's see what I can win. If I roll a 2 or 4, so this is die, so you guys realize that, of course, it's 6 possibilities, so it's 1/6 for each number. So if I roll a 2 or 4, which is 2 of those, right, I win $15. So I win $15, and it's 2 out of 6. And I win $18 if I roll a 3, which is 1/6. And I win $6 if I roll a 1 or 5, and so that's 2 out of 6. And if I roll a 6, I get nothing. So I can put that down there. I win nothing, and that's 1/6. And notice these guys here, those add up to 1 because I'm rolling the die, and those are all the different possibilities. Okay? So if I multiply all that up, I get 0. So this is a fair game. All right, nobody's going to win. On average, nobody's going to win, nobody's going to lose. Okay, but you got to think about it too, right? If I spend $10 to roll a die, 3 ways I will make a little bit of money. You guys agree with that? If I get a 2 or a 4, I basically make $5 out of that, right? It cost me 10, I made $5. If I roll a 3, I make $8 out of that. That's a pretty good deal. But if I roll a 1 or 5, even though I win $6, It cost me $10 to try it, right? So I lost $4, and of course, if I roll a 6, that's brutal. I lost my whole $10. So there's always a chance. So probability is you're always taking a chance. Okay, but in this case here, I played thousands and thousands and thousands of times. On average, I should get, I should basically have no money left by break even. Okay, a fair game. All right, so that is expected value, math fans. Again, just really good use of probability for looking at gambling. I think it's kind of interesting. So anyway, have an outstanding day, math fans. Adios. Goodbye.